Hello, POE students. This is now force vectors. So if you're watching the series of videos together, we just covered one on free body diagrams, and now I'm going to do a presentation on force vectors. All right, so I'm going to try to do something. This, that's better. Haha, yes. Okay, so force vectors. Well, what's a vector? This is where if I was really good at editing, I would edit that one movie with the what is it called? Despicable Me, and one of the bad guys is named like Vector. And it's like talking about have both the magnitude and the direction. So position, force, moment. All these things are something we're going to talk about. Force, vector notation. That's what we're going to talk about, and how you answer some of the questions on the assignment. So vectors are given a variable such as A or B. Handwritten notations usually include an arrow such as A or B, like something above them. Hey, that's a vector. It has magnitude and a direction. Yay, wonderful. And so if we look at a vector, it says vectors, illustrating vectors. This is how we kind of draw them, illustrate them. Vectors are represented by arrows, including magnitude, direction, sense. So we talked about magnitude already. It's the length of the line in the segment. So this is like a free body diagram where it would be like, this would be like a free body diagram where you have a longer line depending on the magnitude. That's the idea. Right here, we have magnitude, and it's kind of broken up into three different areas. So note that the magnitude is the length of the hypotenuse. If you picture this as a right triangle, it's going to be the hypotenuse. Magnitude is the hypotenuse, okay? So we're going to say 3. Magnitude is 3. It's 3 sections here. Not that that really matters, but it is purposely broken up that way. It does have a direction here. So direction is the angle between the reference axis and the arrow's line of action. So we have this 30-degree here, and we have this axis, which is the x-axis here. So the way that you would describe this would be 30 degrees counterclockwise from the positive x-axis. So again, if this was the coordinate plane, we'd have coordinate 1 up here, right? Coordinate 2, because we have the y, say we have the y-axis right here. Let me see if I can do a little sketch. Yeah. So we have, this is the x-axis. We have the y-axis, right? And we're in coordinate 1, so everything's positive. X is positive, y is positive. Over here is coordinate 2, 3, and then 4. Well, so this is 30 degrees counterclockwise. I'm going this way, counterclockwise from the positive x-axis. That would be the direction. What about the sense? Now, the sense is kind of more directional, kind of what we're like, hey, if I'm looking at this visually, it's going upward and to the right, okay? Upward and to the right. So I have to remember that I'm on camera, so it's a little reverse. So upward and to the right. So sense. We're talking about the coordinate plane right here with the axis 0 or the origin or reference point, whatever you want to call it. Again, we have right and up. We have both positives. What about over here? We have down and right. So y is negative and x is positive. And then we have down to the left. We have both are negative. It's in the third quadrant here. And then we have the second quadrant is up and to the left, or y is positive and x is negative. All right, so we're going to do a little trig. And here's a little trig review if you haven't done trig. So we're going to do the simple trig stuff right now. And I'll need to get a calculator pulled up for us. I'll get that ready. So how many of you have had trig? Hopefully some of you have had trig or you're currently in trig. But this is the simple, a very simple trig stuff related thing. Because we're going to be dealing with right triangles. We've already said that the hypotenuse is going to represent the magnitude, okay? So that's going to be our line. Okay, we're going to make sure the hypotenuse is our vector. So a triangle with a 90-degree angle, this is a right triangle. Sum of all the interior angles is equal to 180 degrees. The Pythagorean's theorem, normally it's a squared plus b squared equals c squared. It kind of looks like c squared equals a squared plus b squared. That's a weird way to say it. So we have the hypotenuse here. Theta is the symbol for the degree. We have the adjacent side of theta. This is in relation to theta, by the way. The opposite side, theta right here, is opposite. And the adjacent, and then we have the hypotenuse. So those are the three things we want to focus on. Okay, you might be familiar with this, maybe you're not. SOHCAHTOA, it's a way to remember this kind of thing. The S and the C and the T are trig terms, so sine, cosine, and tangent. And the O and the H and the A and the H and the O and the A are all of these that you see on the right triangle. So the H is the hypotenuse, the A is the adjacent, and the O is the opposite side. But what does that mean? Well, the idea is it's a way to remember that the sine of theta is equal to, and you can kind of put a backslash in here, is equal to opposite over hypotenuse. So it's just a little way to remember these kind of functions here. So the sine of theta is equal to opposite over hypotenuse. Oh, that's kind of interesting. All right, we'll test that out in a little bit. And cosine, the cosine of theta is adjacent over hypotenuse. Well, you might say, well, then I know what tangent is because it's opposite over adjacent. Well, let's take a look. You're right. Tangent of theta is going to be opposite over adjacent. Notice what you have and don't have here. So, hey, if I'm looking for the hypotenuse, then I'd probably use tangent because if I'm looking for this, I most likely have adjacent and opposite, okay? So if you have some of these other things, you can find theta, the angle, but hey, opposite, adjacent, or if you're looking for one, we'll go ahead and go through one of them. So here's the example. We have F being our force in this direction, our magnitude of the vector. Okay, it's going this way. So we're going to talk about, hey, this is the hypotenuse, the magnitude of the force. Okay. In the figure here, we have, oh man, I keep moving myself. The adjacent side, trying to get my pointer back here. So the adjacent side is the x component, F, the force of x. So that's the force in this direction. Now, if you look at the vector right here, it's not fully going in the x direction. So whatever this force is, some of it is going to be going like the force of going on the x direction or the x. I guess it would be the x plane or the x direction. And then we have the y, we have the vertical. So the force going vertical right here. So we have the adjacent, we have the opposite side. So we have the x component, we have the y component, and the forces on each of those. So basically, they're going to ask what's the breakdown. If there's a force going this way, how much is going on in the vertical axis and how much is going on the horizontal x-axis? So then we're going to figure that out. So you could still say, hey, so we're going to replace the opposite and the adjacent, I guess, or the opposite and hypotenuse, rather, because it's opposite and hypotenuse, and we have the adjacent and hypotenuse for the cosine. So take a look, and then again, we have the force on the y and the force on the x. So this is opposite and adjacent right here. So we're not doing any math. All we're doing is saying, okay, if we know SOHCAHTOA, and we say, hey, by the way, the sine of theta is opposite over hypotenuse, then we can say that, hey, we're looking for the forces, so opposite over hypotenuse, right? That's all that we're doing here. And then with a little algebra magic, you can say, hey, if I know two of these things, meaning if I know the force of the hypotenuse and I know the theta, the angle, then I can come up with, using sine, I can come up with the force on the y-axis, right? I can just get y by itself by going, hey, the force, the magnitude of the vector times sine theta is going to equal the force in the y direction or y-axis. Direction is really already indicated with the vector, but this we know it's going to be positive on the y-axis. And then the same thing for cosine and tangent. So we know that, hey, if we know the cosine, well, here, I'll just go for it. If we know the cosine and we know the magnitude, we already know, so if we know theta, we can use cosine and the force to come up with the adjacent side, which is the F, the force on the x-axis. And then using, I don't think it goes into tangent right here, but if you needed to know what is the actual magnitude, and you're given these other things, you can figure out the hypotenuse. Or if you needed to find even tangent, what's the angle? And I know the magnitude, and I know the forces of x and the forces on y, then I can find out theta. So f and x and f and y are negative and if left and down, respectively. So they're not negative in this situation. So then we're going to go, okay, well, then let's actually apply this and see how it works, just so we can get our homework right? We want to get our homework correct. Okay, so we'll say magnitude is 75 pounds of force, all right? And we're going to say this is vector A. So direction is 35 degrees counterclockwise from the positive x-axis, just like their example, except for this is 35 degrees. I think the other one was 30. And we have the sense of right and up. Oh, okay. Right and up. So what's the force of vector A in the y direction? Force of vector A in the x direction, x-axis. Well, it's a right triangle, so we can say, hey, can I take my calculator here, make it a little smaller so I can see the screen here, and say, hey, and I'll make me smaller. I don't need to be that huge. Well, if I'm trying to find the force of 75 pounds and 35 degrees, how much of that force is going in the x-axis, or this direction here? Well, I can use my calculator. I can say, hey, I'm going to use cosine because I'm looking for the adjacent, and I know adjacent, we know the hypotenuse and we know theta, so we can say, hey, let's just use this and kind of switch it up a little bit algebraically and say, hey, I'm trying to get the force by itself. I'll get my calculator back up here. Messing that up. Need to exit it. So how do you do this in the calculator? Well, most of you already know 35 with the trig function of cosine. Okay, 35 trig function cosine right there. I'm on degrees. You might get a different answer if you're on radians. Okay, so we want to make sure we're on degrees here. And then I'm going to multiply that by 75. So about 61.4 pounds of force in the x direction. See this? The force vector A in the x direction or the x-axis is 61.4. Now, before you go, well, what's the remaining, and put that in the y, we have to remember that that's not really the case. Because if we go and do the, hey, what's the force in the y on the y-axis, and we take our calculator again. Come on, calculator. And we take our calculator again and we say, okay, what's the sine this time? So we take 35 and we do the sine of 35 and we multiply that by 75. Well, we have 43 pounds of force in the y direction. Does this make sense? Yeah, well, it does make sense because, hey, look, 35 degrees. I'm more of my angle is going on the x direction than it is in the y direction, right? If I were going 45 degrees, it would be equal. But in this case, we're not. So there's going to be more force in the x direction. So 42 is our answer. Okay, and then they go ahead and they just do a couple more here where they say, hey, 75 now, 35 degrees going down to the right. Well, it's going to be the same except for what's going to happen. There's going to be a negative, right? So this is going to be positive still because we're still traveling positive in the x direction, but we're going to have negative 43. So you should need to know that the orientation or the direction, the sense, so that you can come up with the right negative or positive. Okay, so now we have this problem where they're like, hey, there's pulling a boat, and we're pulling a force of 75 pounds at A and B. Two people are pulling boat, sure, they're pulling the same magnitude. Okay, what's the question? Well, we want the resultant force now. What do you mean? What's the resultant force? Well, if I was going to pull, 75 pounds this way and 75 pounds that way, well, how much force together would we be traveling on the x-axis? Most likely, because that's the direction you want the boat to go. So that's probably what they're asking. So list the forces according to the sense. So label right and up and forces as positive. Label left and down forces as negative. So we have vector A are both going to be positive, right? We're traveling positive direction on the x. We're going to do positive direction on the y. Whereas vector B, we're traveling positive direction in the x, but we're going to travel negative in the y. You can see down here, right? We're going negative in the y on the y-axis. So we're going to do two right triangles now. Sorry. This is the same problem as before, as you know. It's 35 degrees. So we still have our 43 and we still have our 61.4. We're just coming up with the right negative or positive. So the other two are going to cancel out, right? The y-axis, we can see that they're going to cancel out. We're going to be left with x. Well, if we're left with x force, well, what can we do? Well, we can just, we can add them up. This is not a confusing thing. It's just a sum of all the forces. This is in the x direction or the x-axis. So we have, hey, there they are. And the sum of all the forces on the x, this is what they are. And then together, we add them up, we have 122.9 to the right. That's how many pounds we're pulling here to the right. What about, what are we pulling the y direction? Well, this boat's not going to move up or down in our little scenario here or on the y-axis at all because they're going to cancel out. We're still same form. The sum of all the forces in the y, well, we have force of A, vector A and vector B. One's negative. So if we add that together, it's going to enter be 0. So the magnitude is going to be 122.9 pounds. The direction is 0 degrees from the positive x-axis. What's the sense of this thing? Sense is right. Pretty good, right? Pretty easy, huh? It says, hey, draw the resultant force now. Well, that's not hard. It's just going to be a line. Boom. Line. Force resultant, R sub R, that's resultant force, is equal to 122.9. Just an arrow in the right going right. Well, what about this? We have a little different calculation to do, right? So you can break this down into two right triangles and add up the resultant force. Well, what are the vectors here? Well, we have a vector C, 300 pounds force, going 60 degrees clockwise from the positive x-axis, and then we have counterclockwise rather from the positive x-axis.
Teachers, staff, and students, sorry for the interruption.
Oh, jeez.
I do have one bus change for tonight. Bus number 2 will be replaced by bus 13, but it'll still be in the same slot where bus 2 usually is. Thank you, and have a nice evening.
Thank you. Sorry about that. I'm stuck with this pointer right now from from whatever. And okay, back. There we go. I didn't want to have to pause that. So anyway, we'll go back then. Fine. Mr. White. All right, we're going back. So if we look and we say, hey, let's put these together now. Let's actually break these down into individual things. Hey, we have a 300-pound magnitude going 60 degrees. Well, let's go ahead and find the force of y and the force on the x. Well, to find the force on the x, use cosine. Because why is that? Well, because it's adjacent. Looking for the adjacent over hypotenuse. Sakatoa, C-A-H. So ultimately end up with this little equation here. We take our calculator. Sure, calculator. We're going to say, hey, 60. Well, cosine of 60 is not hard. You can see that it will turn out to be 0.5. We multiply this by our 300-pound vector magnitude of 150. So we have 150 pounds in the y direction. Now, just quick smell check. Is it going to be more or less in the x direction? Well, hopefully you've determined that because it's 60 degrees, we're going to have less force in the x direction. Let's take a look. So I'm going to do this before the other slide and see if you got it right. We're actually going to do the sine now, right? Because we're looking for the adjacent. Sakatoa, sine adjacent over hypotenuse. We're looking for the adjacent. We have the hypotenuse, and we have theta. So, hey, algebra, say, let's get fx by itself. So the sine, we're going to be left with sine of 60 multiplied by 300. 259. Oh, you know what? I messed up along the way. Those are the correct answers. The first one is for x, but I for some reason mixed it up with y along the way. So this one is on the x. The cosine is for the x axis. For the sine that I just did was for the y. So on the x, we're going to be pulling 150 pounds. But on the y, we're going to be pulling 300. Well, sorry. We're going to be pulling 259. They rounded it up to 260 pounds. So we'll have to take a look at this one more time on the calculator. Sokato. I can't believe I'm saying things wrong. Oh my gosh, trig, right? My bad's here. So let's look at the x again. So for the x, finding the adjacent, okay? Sokatoa, so CA, adjacent. So we have the cosine, we have 60, the cosine of this, multiplied by the magnitude. We're left with 150 on the x-axis. What about the y, Mr. White? Well, okay, we'll do the y over here. So opposite over hypotenuse, sine of 60 multiplied by the magnitude, 300. So we have 259.8. They round out to 260. So 260 on the y-axis. All right, well, what does that look like with the vector? Well, here, let's do the other vector, I guess, here. Hopefully we don't mess this one up. Hopefully I don't mess this one up. You guys probably didn't mess it up. So we have the calculator here. And we said, and the reason why I realized I messed up was because it didn't pass the smell test. When I was like, wait a second, well, I have more. I have 250. I have 260. It should be less than 150. Oh wait, I mixed up the x and y. So this is on the x-axis here. Obviously, we're going to have a different direction. We're going to have to be positive for the x force, but we're going to be negative for the y force over here. So just remember that. So using cosine of 30, there's 30, the cosine of this, multiplied by the magnitude, we're going to be left with a 350 357. They're probably going to 356 pounds of force on the x-axis. What about on the y-axis? Well, they're going to take sine of 30, 30 sine, and multiply that by the magnitude, and they're going to be left with 200 pounds of force, negative, so on the negative y direction. So let's see if that's right. 350 and 200. Did I say 350 for that one? Anyway, so we have 350 here, and we have 200 right here, negative 200. So what's the resultant force? Now we're going to basically add these up. So the resultant force is, hey, we have oh, that's why they rounded up quite a bit here. So 346.4 pounds plus 150. And then we have a negative 200 and 260 pounds here. So we have pretty much 60 pounds pulling in the y direction, and we have 496 pounds pulling in the x direction. They might round it quite a bit, so let's take a look. No, they didn't round it at all. So they added those up, those forces up. They have 496 pounds going x-axis, and we have 59.8 pounds going up in the y-axis, so positive up. So what's the sense? This thing's going to actually be pulling, and the vector's pulling is right and up, correct? That's correct, Mr. White. So you can draw the resultant force now. Say, hey, this is the resultant force. We have, and you actually could break this down, and I think they might do that right here, where they say, hey, we can actually go like this as well. There's two ways really to think about this. In order to portray the correct direction for the resultant force, it is crucial that the tail for the first force is the beginning point for the tail of the resultant force. So we are pulling this direction. Hopefully everyone understands that. Okay, and then it's like, but what's the force? What do you mean? Didn't we just calculate force? Well, we didn't really calculate the magnitude of the resultant force. We calculated how much it's pulling in the x direction, how much it's pulling in the y direction. Oh, I bet this is where maybe, Pythagoras theorem comes in. So we're going to say, hey, a squared plus b squared equals c squared here. And as a result, you can take the square root of your answer and get the force. And so we have a 500-pound resultant force. After doing that, magnitude is 500 pounds. Wait a second. Solve for direction. Well, direction of what? The direction of the resultant force. Wait, this is all from the beginning? This is all from right here? This is all from right back to the beginning here. This problem here. We're doing back this right here. Wait, 300 pounds here, 400 pounds there. We have a resultant magnitude of 500 pounds. We're like, oh, wait, that kind of stinks. We're pulling 400, we're pulling 300, and our result is only 500. Well, yeah, because we have some opposing forces going on here. But what direction? We have 30 degrees right here, and we have 60 degrees right here. Maybe you're like, maybe we'll split the difference, right? Well, not really, because we're pulling more force on the 400, right? So on the d vector, vector d. So we're going down here, we're going back, and we're trying to find the degrees using our, kind of going through this, not the degrees, but the direction of our resultant force. This is where tan comes in, the tangent. So we know opposite, we know adjacent, but we don't know theta. Wait, opposite over Jason, we can do that. That's just 59.8 over 496.4, right? Yeah, it is. But how do you have to do this though? Because that comes up with the tangent of theta. Well, how do we get theta by itself? Well, we have to do the inverse tangent. Okay, so what that looks like on the calculator, because that might be an important one, might look different for some calculators that you're using. It might be just a negative tan. It might be arctan. It might have some inverse tan thing on there. But what you can do is you can say, hey, 59.8 divided by 496.4 equals this. And then you can say, whoa, go up to the trig function. And for me, what I do on the computer calculator is I press second, and then I have the inverse tan option. I go inverse tangent. And then I say, wait, is that what it equals? Oh, go. I just blew it. Hold on 1 second. I clicked it twice. Don't click it twice, because then you're doing inverse tan and then another inverse tan. Let's try that one more time. 59.6 divided by 496.4 equals this. We'll take the inverse tangent. And we're left with 6.84. What is that, degrees? Yeah, kind of. They rounded it to 7 degrees here. So that is the correct answer. That's what you'd get. And it's weird how they rounded all of a sudden, but it's 7 degrees. So they're saying it's 7 degrees counterclockwise from the positive x-axis. All right. Lastly, they say, okay, what is the resultant force? Give me all the data. Give me all the information. It's 500 pounds magnitude. It's 7 degrees counterclockwise from the positive x-axis, and we have a sense of right and up. That's it. That's it. Okay, so what I have for you here is the answers. Finally, Mr. White's giving us the answers. So I'm going to attach this so you can check your work and you can submit the correct answers. So I am giving you the answer sheet here. I'm not going to go over it right now because we already went over we just went over the lesson. But I want you to check your work and make sure that you're kind of getting the similar responses to the answer sheet, okay? And then go ahead and submit your Google assignment. If you have already submitted your Google assignment, you can resubmit your Google assignment. I believe you can. If you can't, just email me the new assignment. Anyway, hopefully this is an okay lesson for you today. Get you caught up on the free body diagrams and the vector forces. So glad you watched. Turn in the assignments. Have a good Monday, virtual Monday. Adios.